Welcome back. In this video, we are going to solve a structural design problem that involves a column design using the working stress method based on eStructural Design Taichi found on the App Store. Design a reinforced concrete circular column using working stress method that carries an axial bending load of 100 kips and has a minimum eccentric distance away from the center of the column section. Design criteria as follows: strength of concrete 3000 psi, vertical bars 5/8-inch diameter bar grade 40, spiral tie bars 3/8-inch diameter bar grade 33, steel ratio 2%. The column carries an axial load of 100 kips. Assume a self-weight of 1.92 kips for a total load of 101.92 kips. Enumerate input parameters required. C3 for column name, circular shaped spiral column, footing to second floor column segment, 12 feet unsupported height, 5/8-inch diameter grade 40 vertical bars, 3/8-inch diameter grade 33 spiral tie bars, strength of concrete 3000 psi, 2% steel ratio, axial bending of minimum eccentricity, and total load of 101.92 kips. Solve the balance section properties given Fc prime equals 3 kips and Fy equals 40 kips. We get N equals 9.289, M equals 15.69, Fa equals 1.34, Fb equals 1.35. To solve for column size, we get the reduction factor of 0.741 and the nominal load at 137.54 kips. The gross area of column is 119.6 square inches and diameter at 12.34 inches, round up to 14 inches. Solve the area of steel given the gross area of 153.94 square inches and 2% steel ratio. We get 3.08 square inches. The number of bars for 5/8-inch diameter bar is 9.94, round up to 10 pieces. For spiral ties, the pitch is 1½ inch. The minimum eccentricity for circular column is 5% of its given diameter, which is 0.7 inch. The balance eccentricity of the given section is 3.25 inches, greater than 0.7 inch. Therefore, the section is compression controlled. Solve for moments. Bending moment is 96.28 inch kip. Moment of inertia is 2501.25. Solve the actual stresses. The actual axial stress is 0.89 and the actual bending stress is 0.27. The combined shear and moment stress is 0.864, which passes the adequacy test. The design results for our problem are as follows. Fc prime equals 3000 psi, Fs equals 20,000 psi, column size at 14 inches by 12 feet, vertical bars at grade 40, 10 pieces 5/8-inch diameter bar, spiral tie 3/8-inch diameter at grade 33, pitch at 1½ inch on center. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.